Hey, what's going on, guys? Wanted to show a pretty cool little video that little script that I wrote in Python. So I'm going through and relearning pre-algebra and algebra and all that good stuff. And so I figured, hey, well, data scientists and math scientists use Python for mathematical stuff. I use my Python skills for my, networking stuff for the most part. So let me go ahead and try some really cool. Let me try some of the concepts that I'm learning in this math class that I can apply into Python. And so one of the things that I'm going over is it's basic, but identifying factors of a number and then identifying whether the number is a prime number or not. And just a refresher, a factor is whatever number, well, it'll be whatever natural numbers that are multiples of a specific number to get a product of a number, if that makes sense. So essentially, a factor of four would be two and two, or one and four. Um, those are factors. Those just the two numbers that are in the multiplication side of the equation. That makes sense. So um, in this script here, just going over some of the two routines that I wrote. Oh, two, yeah, functions that I wrote. One function is to actually retrieve the factors, and then one function is to actually get the numbers. And I'll step through, or check if it's prime numbers or not. So I'll just step through to see, let you guys know, explain to you guys how this is working. So in the get factor, what we're doing first is we're creating a list called factors. This is going to be used later on. So after that, well, first off, we'll go at the definition. Well, we'll start from the start. We'll start from the top. I'm actually not using this math package, so I can actually get rid of that import statement. But so first off is we're defining the get factor function, and then it's taking an input parameter of number. We're creating a factors variable. We're creating a list variable, and then we're going to run a for loop, and we're just going to say for num and range number. So it's going to start from 0 to whatever the number is that I put in for the actual input parameter. And so one of the things that I had to do here, because what ends up happening is that it'll try, if I just left this line out, well, actually, if I left this line out, what would happen is I would get an error because it's going to try to divide or do the modulus of a number by zero, which is not permitted. So, in order to prevent that from happening, I have to do a plus one on the initial index number here because it starts from zero, it doesn't start from one. So, that forces it to start from one. And then what I'm going to do is I create a variable called modulus number, which will take the modulus of the number. So of the number divided by the number that is inputted, get the modulus by the addition, the new index number. Um, so what ends up happening is that what a modulus is that it returns the remainder of the number, and I'll explain to why I'm doing that with the modulus. And then the division is just the regular division operator, where it's going to take the number and divide it by the new index number, incrementing it by one for each number in the range. Um, Now, once that is done there, what'll end up happening, it'll run an if statement. It'll say if the module num is equal to zero, which means that if I get a modulus that returns back zero, which means that there's actually no remainder of that program, of that particular equation, what ended up happening is that I'll append the number that was resulted from the division action into the factors list, and from there I'll return the factors list. And so I have a test function. I'm just gonna keep this check prime one done, and I'll show you guys. So we'll just do this for the number 30. So it's gonna bring back the factors of 30. So run it, and so these are the factors of 30. So the way that I envision this is that at the end of the day, whenever you're doing a factor or something, it's always going to start with the factor itself and the lowest number being 1. So 1 times the factor will always be a part of it, and that'll be your starting and end point of your factor discovery. And then from then, you would just have to find numbers in the middle that are evenly divisible into the starting number, which is 30. And so 30 has 1, 2, 3, 4, 5, 6, 7, 8 factors. And what's going to end it, and so that's essentially what I'm extracting here with this function here, right? And so what I wanted to do is also have the ability to check prime numbers. Um, and so I figured the easiest way is that I already have a. So first off, a prime number is a number that has factors that are only divisible by itself in 1. So 30 times 1, a good example of a prime number is 2. So if I change this test number to 2, 2 is a prime number, right? So 2 and 1. Um, so I needed to have a way to validate whether I have a prime number or not, and so I wrote another function that says check prime. Now check prime is going to actually just walk you guys through it. It's going to take the same input of number, and what's going to happen is it's going to do a get the factors of that number. So I'm going to run my get factor function that I created there earlier, and then it's going to return the list of the factors like you see down here. And then he's going to get that, and he's going to check the list of those factors, the length of those factors. Now if those factors are equal, if that length is equal to 2, which means that there's 2 items in the list, I'm going to return prime. Else, if it does not equal 2, it'll return not prime. Now let me go to get rid of this because that should not be there. Put that earlier, and we'll go ahead and run the check prime, and then from there it'll come back, and as you can see now it'll say prime. And let's change this to a non-prime number. 4 isn't a prime number, so we'll go here. It'll come back and say not prime. And let's see, 1600. That should be not a prime number. Yeah, but I just came up to try to do this. So I figured I try to practice some of these concepts that I'm relearning. Let's say um, into the programming side to keep that piece still strong. So if you guys are coding and you don't normally code for stuff like this, it's good to do practice just to hammer in some of the actual methods of the actual language that you're working with. So I'll turn around and do the same thing in Golang here in a second. But this is just a quick video I wanted to show you guys. Just some cool things that you can do with Python, and that could pretty much be practical. I mean, I can use this now as a calculator for later on if I ever need to use a function for prime numbers or whatever the case is, which definitely comes into play with cryptography. I can use these functions that I wrote just playing around, doing regular math. So, wanted to show that to you guys. All right, later.